Excellent. So this last exchange segues very nicely into the topic of our next and our final presentation of the day. We've spoken a lot and we've seen a lot of very real examples of the implementation of AI, how it can impact in healthcare, in entertainment, in education, in infrastructure. What we're going to be focusing now, a slightly macro view, why it takes a data-driven organization, not a micro team perhaps, but a data-driven organization to fully leverage the benefits of AI. It is my distinct pleasure and honor to welcome to the stage Dr. Edeltraud Leibrock, who is a senior partner, digital and global managing director, no less, at Roland Berger. The stage is yours. Thank you, Doctor.
Thank you very much. Yeah, actually, the term AI was just mentioned, has been around for a quite long time. Actually, it was John McCarthy who coined it in 1955 as a marketing thing, because he was applying for government money for the Dartmouth conference. And that was when the term AI, artificial intelligence, actually was born. So why it takes a data-driven organization, that I think fits very closely to the talk of the gentleman before me. And when we talk about AI today, we mostly talk about Gen AI. But surely Gen AI is not the end of the story, it's just the beginning, I think. Gen AI, some people even think we have artificial general intelligence now, which is not really the case. Gen AI today is still a narrow AI, like every other AI also. But when we talk to our clients as consultants, they are mostly interested in use cases. So I will talk a little bit about use cases also. The rise of Gen AI, of course, is due to more computing power, greater memory stores, faster machines, and so on. But the most important factor really is that for the first time in human history, we now can talk to the machine in natural language. And that really fostered this explosion of Gen AI and the explosion of the use cases. And when we talk to our clients, use cases are kind of popping up like mushrooms out of the forest floor. And that's a good thing as long as people are still in an experimental stage and trying out things, and then they start building their little data lakes under every single use case. That's good for 3 or 5 use cases, but imagine you have 300 or 500 use cases and all these little data lakes. You'll get a data landscape that will be more fragmented than any legacy you have ever seen and everyone has been complaining about. So it has something to do with data, how efficient these use cases really can become. On the other hand, talking about mushrooms, they can be poisonous also, you know. And there has been, just to mention the Microsoft chatbot Tai, which was trained with then Twitter data, and it became toxic very, very fast. Actually, it was not due to the chatbot's DNA, the algorithm. They even tried to tweak the algorithm a bit, but it was too late. It was trained with toxic data. So this can happen. It shows, again, how important really data is for the right use of AI. So I'm going to tell you a story. I call it fun with ChatGPT. And when I'm asking ChatGPT, for example, and now I'm talking about quantum, that was also something before. what is the quantum mechanical effect that's behind quantum key distribution? Most people will answer, I don't know. Some may answer, well, it's Heisenberg's uncertainty principle, because that's the only quantum mechanical effect they know. In this case, ChatGPT gave the same answer, which is wrong. And I politely, as ever, said, well, I think in this case, it's the Einstein-Rosen-Podolsky paradox. And then ChatGPT said, yeah, well, you're right, it's the Einstein-Rosen-Podolsky paradox, and it gave me a wonderful definition. It was all correct. But that means, that example shows, machines don't really understand. These large language models function differently. They are just linear equation systems, very huge linear equation systems with threshold parameters, and you tweak the individual equation parameters with training data until the outcome fits the target function. That's basically it. What else do? They even sometimes, as in my example here, they hallucinate. I'm not talking about magic mushrooms now, but hallucinating models. What do we do with people who hallucinate? Actually, we help them, we calm them down, we ground them in reality. And the same we do with models, we ground them in data. And grounding needs data, and data to be meaningful need context. Because whether you talk about natural intelligence or artificial intelligence, no context, no intelligence. That means all intelligence really needs context. If you put a person out of context, fly them to Mars or whatever, without the context, they can't really survive. So, and there we have the same data problem everywhere, basically. The gentleman talking before me said, especially in legacy architectures, where data resides in silos, it's very hard to create a context that is useful and meaningful across silos. And I tell you about a rough experience I personally had when I was trying as the COO of a financial services institution to build a data integration layer across the data silos we had. Here you see, could be the skyline of Qatar. Well, no, that of Doha would look a little bit more glamorous than that. It's actually a picture for the architectural silos you find in a bank. That could be retail banking, corporate banking, finance and risk, whatever you can think of. And the data actually resides in those silos, isolated. The meaning of the data is only clear from the silo it's sitting in. So what we wanted to do is break up the silos and actually build a layered architecture with the operative systems here at the bottom and the dispositive systems, the analytical systems at the top, and a data layer in between, like a single source of truth. So how do you do that? You could use different methods. First of all, you could use all the data silos, you remember, sitting in these high-rises and pouring the data together into this data integration layer. But the problem is you lose the information that's inherent in the silo. So what you'd get in that model, if you do that, I wouldn't call it a data lake, I'd rather call it data soup. And you can't then pick it apart once you have data soup. So that's maybe not a good way to go. What we tried is to build a unified data model across the whole bank. And that proved to be very, very cumbersome because you have to adjust data definitions with all the organizational units involved, and they have a very good, they have a right for their data definitions because that makes sense for them. So getting everyone to agree to a joint definition is virtually impossible and will take you forever, and the world is moving on. So unified data model, it can work, but in most cases I have seen also as a consultant, it never worked really. But don't despair. There's a way to do it. You can build a logical layer over the data silos. You have seen, we also heard the term in the last talk actually. You can build a semantic data layer over these data silos. And how this works, I'll explain a bit. Semantic graphs is also something which is not new. Actually, it was invented in the late 1950s when people first tried to bring language to the computer. It was Margaret Masterman, and then later on Niklas Luhmann used it to build society models with semantic graphs. And it works actually like language. Language consists of nouns and verbs, and so does a semantic graph. It has nodes and edges, and I'll show you how that would look like in a very simple example. Here you see a simple graph, a simple ontology with Leonardo in the middle. He was born on April 15th, 1452, in a small village called Vinci, which is in Tuscany in Italy. And he was a contemporary of Michelangelo, who was also an artist. Michelangelo was a bit older than him. They both knew each other. They weren't close friends. Michelangelo is famous, for example, for creating the David. Leonardo created Mona Lisa and The Last Supper. He lived after Vinci. He moved to Florence, where he did his apprenticeship, then moved on to Milan. He worked for the Sforza family, especially Ludovico Sforza. He spent some time in Rome, and so on. And not everything that I've told here is shown in the graph, but you could all bring it to the graph. Graphs can be super complex. They can grow over time. So you can start in one domain, put another domain in parallel, link it together, and it grows like an organic network, more or less. We did that to show you an example. I don't have the demo here, but we did that and built these yellow bubbles into an ontology, and that's actually a banking regulation, which is the ontology here. It's called ANA credit. That I spare you to explain. But yeah, you see, it's really used in real world, and it works actually. So if you really want the full lecture on semantic graphs, I'm happy to give it to you, but not today, because that's then exploding the time, but you can contact me. I'm not quite done yet, because I have still good news and some bad news. The good news is now we've solved the data problem, at least to some extent, but that's not ensuring success of these big transformation projects alone. But good news is transformations rarely fail due to technical reasons. You'll find a solution, I'm pretty sure. But the bad news, and that's something we see as consultants very, very often, there's a lot of reasons for failure, and most of them have to do with the human factor, be it coordination, be it clear about the results, the outcome of a project. The goals can change over time. People don't agree clearly with each other. It can be politics going on, whatever. So besides a data-driven organization, which is pretty clear for success of these transformation projects, AI transformation projects, it also needs a culture of working together. So we can talk a lot about AI, but we should never forget the human factor in all of this. And we should never forget that all intelligence needs context. And yeah, last but not least, AI is for Team Human. And with that in mind, you can sail the waves of change unafraid, and that's what we are helping you with. Thank you.
Thank you so much for that talk, Dr. Leibrock. So I know we will have lots of questions, so we'll just make time for one from the crowd. I'm really interested from a consultancy perspective. What would you say is the main barrier in the teams that you work with to the successful adoption? What's the one thing, if you had a new team who was considering making this journey, that you would say to them, I know that you're worried about this, but let me show you how it can work?
Yeah, it's actually what you addressed
Okay.
before. So the combination of having kind of a vision, a leadership vision, doesn't mean that you need to decline it down to the very, 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 very details.
Okay.
So you need a big vision, and you need leadership as role models and also open for change themselves, because AI also changes their role, the leadership role really a lot. And then an innovation, an organization which is playful enough and has enough room to experiment, to try out, to innovate. Innovation never works when people are under pressure and are kind of
Siloed
tied
in,
up,
yeah.
and siloed in, and I need to be innovative. That doesn't work. But innovation is something that happens if you really have an open mind, a wide, also broad knowledge. Yeah, that's also part of it. And then tying loose ends together, and this I've seen somewhere else in a very different field. Oh, that could work for me. Maybe this way, I'll try it out. And if that comes together, the leadership vision and the openness to change with that room to be playful, I think then organizations cannot fail. And then they don't need us.
Well, look, let's not do ourselves out of a job. So I have time for just one question from the floor. We're a little tight. Is there a specific question that we need to get to? To the gentleman in the fourth row? Sorry, we'll give you a microphone.
Thank you. For semantic graph, what is can be starting point if we need to learn more about it?
So what is the starting point for a semantic graph?
Yeah, you can start basically anywhere in your organization, because you have, let's say you want to build a use case in a certain area, like my unaccredited regulatory use case. Banks have to deliver loan-level data to the supervisory authorities, and that's for now that was filling it into Excel sheets and then submitting it to the supervisory authorities. So you could start there with this very small yellow ontology. Then you have maybe another very different question you want to solve. You build another small ontology, maybe a third one, a fourth one. You link them all together, and then also machine learning comes into play, because you don't have to do all these ontologies purely manually. They once the core is set up, you can use machine learning AI to expand the graph. And it's just about starting somewhere, actually. And I've talked about the 1950s. In 2012, Google reinvented for themselves the semantic graph as their knowledge graph, Facebook as their social graph. Yeah, all hyperscalers use these structures, and you can imagine what amounts of data, ever-changing data, they can organize with this method. And it's important to have the context, for example, to have a very fast web search.
So, on that note, it remains for me to thank you so much, Dr. Leibrock, for your presentation. Ladies and gentlemen, Dr. Leibrock.
Thank you.
Thank you. Thank you so much. Thus concludes track 1 of the summit. It has been an absolute pleasure having you. I want to thank the speakers. I want to thank the guests, especially the guests who asked such insightful questions. There's a brief pause now for refreshments. Then please make your way to the main stage, the beautiful main stage, for the closing remarks and plenary. Thank you again.